Hi all. Welcome as you're coming into the Stewardship Network's monthly webcast. We're going to let you all kind of file your way in here. Randy, welcome. Tony, good to see you. Gordon, great to have you with us. Go ahead and drop into the chat where you're tuning in from as we're letting everybody in. Laura, good to see you. Glad to have you back. Lily, glad you could join us. Let us know, Crystal, let us know where you're tuning in from. Jacob, go ahead and drop into the chat where you're tuning in from. Introduce yourself as we're just letting folks just kind of file in here. Emily, good to see you. Barbara, glad you can join us. We'll kick this off here in just a second, but take a moment and great to have you with us. Crystal, good to have you from Ontario, from Houghton, tuning in from Onekama, as we always say in our family, one comma. Great, Brett, to have you from upstate New York. Go ahead and just drop it in there and we'll go ahead and kick this off. I want to welcome you all to the Stewardship Network's monthly webcast. Great to have you with us. Always a pleasure to be here on the second Wednesday of each and every month. And I'm really pleased to be here with Tyler today, Tyler Mitchell from Huron-Clinton Metroparks Authority. For those of you who may be new to the Stewardship Network, we are a 501c3 nonprofit with a 20-year award-winning, national and international award-winning history. We serve 20 geographically place-based member communities from the Great Lakes to the Pacific Ocean, and we have inquiries from a couple other folks that we're entertaining right now. And so if you're interested in learning more about our member communities, I encourage you to reach out. And as I said, these free monthly webcasts happen on each and every second Wednesday of the month. We've been doing them for more than 15 years. We've done hundreds and hundreds of these. And so we welcome this chance to gather on each and every second Wednesday during the Eastern time zone's noon hour, Pacific Coast 9 a.m. hour, and learn from each other. Our mission is to connect, equip, and mobilize people and organizations to care for land and water in their communities. And so we mobilize in all kinds of different ways to make ecological stewardship accessible to all. We do that through all kinds of different things, different elements of land stewardship and ecological health, invasive species, prescribed fire, strategic planning, all kinds of different ways that we mobilize people. We equip member communities and so that they can pour thousands of hours into their local ecosystems. We do that through stewardship training, leadership development, event registration, backbone grant management, fiscal sponsorship, and those kinds of things. We connect in all kinds of different ways. We're all about connections. And we like to make sure that we can bring people together through lots of different ways. The monthly webcasts are one of them. Field season is coming up. We're looking forward to people being out in their local ecosystems doing stewardship work, and we can help you. Lots of different things. The events calendar is blowing up right now. If you have events that you'd like to encourage people to attend, I encourage you to go to the events calendar, stewardshipnetwork.org/events. We've got our job board also blowing up as field season is happening. Lots of people looking to hire and looking for jobs. As I always say, I love the time that somebody reached out and said, hey, just want to let you know that our top 3 candidates all said that they learned about this job through the Stewardship Network job board. So go ahead and post your jobs, look for jobs, find things. Gloves for Good. We have free gloves that we can use to equip you and your volunteers and your crew. And just even if you just want them for planting a tomato, let us know and we're happy to. You can pick them up in our office and we offer them for free, or we just charge a shipping cost for them. So, as I said, I'm here with Tyler Mitchell from the Huron-Clinton Metroparks Authority, and really pleased to be talking about aquatic resources, challenges, opportunities, and management. And so with that, Tyler, let me turn it over to you to take it away. I encourage you all to also drop into the chat any questions that you have or in the Q&A, and we'll keep an eye on those.
Great, thank you, Lisa. So as Lisa said, my name is Tyler Mitchell. I'm the Chief of Natural Resources with the Huron-Clinton Metroparks. We're a regional park system. We cover 25,000 acres in Southeast Michigan in 5 counties, and we've got 13 parks and pretty much every type of ecosystem that you can find in Michigan or in Southeast Michigan we have. So I'm here today to talk a little bit about aquatic resources. That's a huge and very broad topic, but we want to talk a little bit today about some of the challenges that we face with aquatic resources, some of the opportunities we have for improving them, and some of our techniques that we use at the Metro Parks and some of the novel practices that we use in order to manage those systems. So I've got a lot of content to get through today. I'm going to go through pretty quick, but there'll be plenty of time, hopefully at the end, for some questions and follow-up. So let me start off by, what are aquatic resources? We're talking today about lakes, rivers, streams, and wetlands. Pretty much anywhere you have water on the ground in Michigan is an aquatic resource, whether it's a small vernal pool that's there for a small impact in a short period of time, or whether it's a multi-thousand acre lake system. It is all important to what we do and how we manage these systems. So again, as the title said, we're going to talk a little bit today about some of the challenges. There are a lot of challenges that face aquatic resources and aquatic systems. Try not to get too negative, but want to go over some of those challenges that we face with managing these systems. Talk about some of the opportunities for improving the state and the health of these ecosystems, and some of our management techniques. So in Southeast Michigan in particular, but really increasingly across Michigan, we've got urban landscapes and urban watersheds. So you can see in the map here, the gray shape is the urbanized area in Southeast Michigan, as the state considers it. And then the red outlines, those are our parks. So those are the tiny green islands in the middle of that big gray blob. So wanted to talk a little bit about urbanization and watersheds. Urbanization does create stress on our watersheds. Hydrology is interrupted, channeled, blocked, and polluted. A lot of times as we settle in areas, the first thing to go are wetlands, streams are rerouted or dammed or moved, and that creates a lot of pressure on these systems. And then the adjacent urban sprawl does create a lot of pressure on the remaining green spaces. So as you can see, those red areas, those are our parks in Southeast Michigan. Those are some of the only green spaces in this entire area. So as we have increased urbanization and a larger amount of communities relying on those smaller and smaller green spaces every year for recreation, for things like carbon sink for drinking water, for stormwater absorption and storm event buffering. So as the urbanization increases, the pressure on our remaining green spaces also increases. So I want to go over a few of those urbanization pressures, some of the things that are a result of our increasing development, especially in Southeast Michigan, but really throughout the state. The first one is hardscape. So essentially paving or creating buildings or other features on top of what was natural area. That's going to, obviously, if there was water sitting on the ground before, there's still going to be water in that area, but it's not going to be able to penetrate into the ground naturally. So it's going to have to go somewhere as we create more hardscape. Hydrological interruptions. So as we move into cities and create roads and buildings, a lot of times rivers and streams and wetlands get in the way. So what we do is interrupt that hydrology. We maybe shift the path of a river around a city rather than build around the natural river corridor. So you can see that kind of in the bottom left photo there, where a river is sort of channelized into a concrete sort of channel rather than be allowed to continue on its normal natural course. The loss of the natural floodplain. On the top right there, you see a photo of a severe flooding event. A lot of that is because we've lost and developed a lot of our natural floodplain. Rivers go through a natural seasonal and cyclical period where we have heavy rains and the water that would normally go onto the floodplain has nowhere to go because it's been developed. And a lot of times you end up with these massive flooding events. And there's been some in Southeast Michigan that have made national news. Runoff and sedimentation as well. As we continue to develop these areas, there's going to be runoff from our lawns, from our golf courses, from our buildings and other roads, parking lots and hardscapes, and all of that is going to increasingly put pressure on these aquatic resources. As I just said, kind of on the lawns and golf courses, nutrient loading or fertilizers that we use to maintain golf courses or lawns those are going to get into our natural waterways and increase the nutrient load or eutrophication. And we'll talk a little bit more about eutrophication. Habitat loss and fragmentation. Again, as we construct features on the landscape, a lot of times we're cutting in half a wetland or we're paving over something entirely. And that causes a lot of effects on wildlife as that habitat is either lost completely or fragmented where it's interrupted. Water quality reduction, again, as all this water is running off of urban areas, all of the brake dust in your car, the grease, the oil, all of that stuff gets introduced into natural waterways. And then also, all the other pollution that comes with development. Drinking water impact, the Stewardship Network is based in Ann Arbor, and I know there's probably some Ann Arbor folks here, and you all are very well aware of some of the threats of drinking water. And as these water bodies or aquatic resources that we rely on for drinking water are polluted, it becomes a real threat of where you're going to get your water from. Climate impact as well, all this urbanization, pavement, hardscape, and interruption of the natural floodplain can create heat islands, can remove things that would otherwise sink carbon, like forests, wetlands. Those are great carbon sinks, and as we lose those, we're going to have an increased impact on climate. And then combined sewer overflow. That's something we'll talk about a little bit more in detail, but one of the increasing pressures of urbanization is you have more sinks and toilets flushing. That water has to go somewhere. So where does that go and how does that impact our natural aquatic resources? So first I wanted to talk a little bit about pollution, particularly non-point source pollution. Now this diagram here has both non-point and point source solution, but I wanted to talk a little bit about the non-point source solution. So this may include physical, chemical, and temperature elements, something that you don't necessarily think about when you think pollution. But things like hot or cold water that's introduced into a stream or a river may cause a lot of natural interruption of natural processes. And then physical interruption, things like sedimentation can have a physical impact on the aquatic resource. Chemical, like we talked about, nutrients and runoff and things like that. So all of these non-point source pollution issues cause a degradation to the water quality, and those degradations carry downstream. A lot of times you're sort of at the mercy of what happens upstream to what the water quality is like in your neighborhood. Because of these non-point source solutions, and let me just look at a couple here on the diagram. You've got urban streets, you've got rural homes, suburban developments, but particularly cropland and animal feedlots. Those are huge sources of non-point source pollution. With cropland, you've got a lot of nutrients that are used in agriculture that run off into the river. And then animal feedlots, obviously, the fecal material, E. coli, all of that rain falls on that landscape and washes all that into your river. So these are non-point source pollutions. These are very difficult to attribute the source because it is so diffused over a large landscape. And it's very difficult to eliminate. There's a diffuse responsibility because it's hard to point fingers at exactly where this pollution is coming from, because it's coming from a landscape wide. So some of the sources for non-point source pollution. On the left-hand side there, you see obviously an agricultural area. Agriculture has gotten to the point where we've have essentially less agricultural land every year, but higher productivity. So we've gotten to sort of the technological pinnacle of increasing our number of bushels per acre, the productivity of these landscapes, of these farms. The small family farms are almost gone at this point. Most of these are large industrial operations. And part of that is fertilizing, growing GMO crops and putting a lot of fertilizer on them to get the maximum yield per acre. That's sort of modern farming. And that can cause what you see on the left here, as if you fertilize and then the next day you have a rain event, a lot of that fertilizer is going to get washed into nearby water bodies. And that's what you see on the left there, as that fertilizer, which is plant food, is introduced into the body of water there. You've got an algal bloom occur. In the center there, you see kind of some construction activities, and this is another cause of non-point source pollution in the form of sedimentation often. So you've got a construction crew working there, and they have a couple of best management practices in there. They've got a turbidity curtain, and they've got a, you can see the pile driven there, and the walls, and they're trying to manage their sedimentation, but you can see the creek is still very muddy there. Still a lot of sedimentation that occurs. So whether it's, like this, installing a bridge or walkway, or if it's a neighborhood, anytime you have bare soil, you're going to have rain and you're going to have runoff and sedimentation. And then on the right-hand side, they're very familiar with this in Michigan, where we use salt in the winter to help keep our roads safe. And it's obviously a human health and safety concern, so it takes a lot of precedence over the environmental health and aquatic resource ecology. But you see there the salt kind of stained on the road. You can see how much salt is put down often on these roads, and you can actually see where as either the ice melts or you get a little warming period and the rain comes, that is conveyed directly down those drain pipes on the bridge and then into the river. So a lot of introduction of salt, there's a whole lot of information out there about its detrimental effects on aquatic resources, particularly wetlands, where you can see that seasonal influx of a salinity change has a lot of negative impacts on aquatic ecology. So some of the effects of non-point source pollution. On the left here, you see sedimentation. So obviously it's a, sediment in the water. It kind of creates this murky, muddy water. So that can reduce your oxygen in the water column, both by interrupting the physical gas exchange and also by, the next bullet point there, the light penetration reduction. So as you've got light less able to penetrate in the water column, you may have plant die off below that murky water, which will then continue to consume oxygen, and that will create an oxygen reduction in the overall water column, which can lead to negative impacts on aquatic animals. And then just a physical interference with biological processes as well, things like sessile invertebrates like clams, mussels, all of those things that could end up being buried essentially by these events, to the point where it's interrupting their actual biological processes. In the center there, nutrient pollution. Nutrient pollution generally comes in the form of phosphorus or nitrogen pollution. Those are things that we put on our lawns and then our crops in order to increase their productivity and help them grow. When those things get washed into the water column and get downstream, they can increase your overall algal production. Algae are essentially waiting for two things: temperature and nutrients and sunlight. So if they get a big influx of nutrients, they're able to take those nutrients up very quickly, more rapidly than your macrophyte or your true plants, your rooted plants, and that causes an algal bloom. This can also create an algal community shift and kind of favoring the species that take up those nutrients most rapidly, especially in the case of nitrogen, where you'll have a blue-green algae take up, which are existing in the water column all the time. And when those nutrients get introduced, you can have a shift in that community, excuse me, as the algal species that are most rapidly able to take up the nutrients will be favored. Overall weediness increase in your lake as well. Obviously, you're introducing plant food to the system, so you're going to get plant growth, and that's going to create a more weedy bottom of your lake. It can interrupt ecology, can harm fish species, sporting species, and interrupt your recreation as well if you can't get through your lake because it's so weedy. And general accelerated eutrophication. So eutrophication is a natural process whereby a lake or aquatic system will move from a low nutrient system to a middle nutrient system to a high nutrient system, which is called eutrophic. So that's a natural system that occurs a natural process that occurs over time. But with this anthropogenic introduction of nutrients, you've got increased accelerated eutrophication. Once those nutrients are in your system, they're very hard to get out. There's very few ways, unless you have water exchange with these nutrients moving downstream. Very hard to get them out of the system. They're taken up by plants. They're then in the system. If those plants die, the nutrients are released and they're taken up by other plants. So once you sort of migrate down that scale towards eutrophication, it's very hard to come back from that. And then the last picture here on the right, you see a fish kill, which is an unfortunate reality in a lot of lakes in Michigan. And this can be caused by a number of issues. A lot of times it's just over winter. There's some interruption in processes that cause this, but it can also be caused by a chemical or thermal imbalance, changes in salinity, as we talked about with the road salt, changes in temperature. Fish and other aquatic animals are really reliant on the ecosystem around them. They're cold-blooded, they live in the system, and there's no way to get out of it. So this can affect a lot of the biological processes of fish and wildlife. One of the major things is thermal refugia, or areas where fish can get out of the heat, get into a colder area where they're going to have more favorable biological processes where they're able to slow down their metabolism. With a thermal pollution event or something like that, which can come from a power plant or something like that, you may eliminate those refugia. You may eliminate some area that fish are able to spawn or hide out from that heat. So point source pollution, this is the other type of pollution. This one's a little bit easier to think of conceptually. It's something coming out of a pipe that shouldn't be, right? So we talked a little bit about combined sewer overflows. So on the bottom there, you see a diagram of a combined sewer and some of the effects that can happen during weather events. So on the bottom left there, you see what the system looks like in dry weather. You've got water coming from the community in the form of sinks and toilets, sewage from domestic, commercial, industrial sources. It goes down the pipe and then goes to the water treatment plant. In wet weather, when you've got a lot of rainfall, you've got that water being conveyed down storm drains, down downspouts into the same pipe, and it's mixing with that sewage. And then when you have an overflow, like you do on the bottom right there, there's just too much water for the wastewater treatment plant to be able to handle. So some of that water goes over the dam and is diverted out into the river. So you've got raw, untreated sewage heading out into the river. This is something that's very closely monitored in Michigan. I know that the communities, especially in Southeast Michigan, are really trying to prevent these overflows by either increasing capacity of the pipe or by separating their systems, where sewage goes in one pipe, stormwater goes in another pipe. That's ideal, so that you never have sewage being introduced into a system. But that is a potential point source pollution event. And this does happen in Michigan, in particular in Southeast Michigan. It happens, maybe a few times a year, but they're closely monitored and regulated. And then on the top there, you have a wastewater treatment plant. This is essentially where all that sewage goes to, in a closed system, where all the sewage and sinks and toilets go to this plant where it's treated, where they treat for things like temperature, ensure that the water being released into the system, into the aquatic system, is the right temperature, that it's sufficiently oxygenated, that it's got no pollutants in it, the nutrients, and they've got a lot of conditions of their permit for the facility that govern what the water needs to look like as it leaves the system, as it leaves the plant into the aquatic system. But in cases where that goes wrong, you can have a point source pollution event coming from a wastewater treatment plant. So I wanted to talk about a couple of those events, in particular, these point source pollution events in Southeast Michigan that we have been dealing with, and particularly at the Huron-Clinton Metroparks, a couple that I have had experience with on the Huron River in the last few years. So this is August 2018. Many of you probably know that a facility called Tri-Bar Manufacturing, there was a PFAS pollution event. So PFAS is a family of chemical substances, which includes PFOS and PFOA. Hard to get all these acronyms straight, but it's a huge family of hundreds of chemicals. These are industrial chemicals, which are hydrophobic, and they have human health and safety concerns, being carcinogenic, causing fertility issues. These are chemicals that are often used in waterproofing of leather material for boots, Teflon for pans, and also in the case of this particular plant for vapor suppression in an industrial process, because it's hydrophobic. It helps keep down vapors coming off of their industrial processes. Due to their man-made nature, their environmental fate, or what happens to them when they're introduced into the natural environment, is very poorly understood, because they're not supposed to get into the natural environment. And they're often called forever chemicals due to their extremely slow breakdown. Being hydrophobic and being introduced into a water column, they're obviously going to be fighting the natural breakdown processes that would otherwise occur in a water column. So this was a release in 2018, August, that was released from Tri-Bar Manufacturing. The water went to the wastewater treatment plant in Wixom, but they were not aware that there was going to be PFAS in the water. So that was subsequently released to the Huron River. This caused a huge problem on the Huron River, a lot of interruption of recreation, of, just people being out on the water, fishing, boating, taking their kids to the beach. So you can see on the top left here, that photo is the PFAS pollution events in the state of Michigan. So you can see this is a huge problem across the state of Michigan, particularly in southeast and western Michigan. In the center there, you see that foam. That is a PFAS foam. So that's kind of one of the telltale signs when you get this washing action on a shoreline. You get this foam buildup, and if it doesn't look, there are natural foams as well that are kind of more yellow white and a little bit looser. This is a very thick, much whiter foam. So if you see something like that, it may be a potential sign that there's PFAS in the water. Then on the top left there, that is a sign that we worked with the DEQ at the time, now Eagle, and the Michigan Department of Health and Human Services to develop these signs for our parks in multiple languages. And this informs the public of the do not eat the fish advisory. So essentially there's an advisory from Kent Lake in Kensington Metropark, which is kind of in the middle of the Huron, all the way down to Lake Erie, that you're not to eat any of the fish, any species, any amount, anytime, because of these PFAS pollutants. So the next event I wanted to talk about was happened recently, February of 2022. This was a fuel spill near Flat Rock, Michigan, which is again on the Huron, a little bit further downstream. There was a legacy underground storage tank for fuel on an old Ford property. This was, used to fuel the company's vehicles, and it was sort of abandoned in place or left in the ground with fuel in it. So the tank was nearly 100 years old, had a 10,000 gallon capacity, so quite a large tank, much larger than most facilities would have. There was an undetermined amount of fuel left in it. And essentially, once the tank started to break down after 100 years, this fuel was introduced into the groundwater and then conveyed into the Huron River. And it took a while for folks to figure out where this was coming from. Even though it was a point source coming directly out of that tank, there was a lot of investigation needed to occur to find out where this was coming from. The current owner of the property had no idea that there was a tank buried in there, or that there was any fuel, that there was anything needed to remediate. So it became a major issue. And then on the bottom left, you can see there, made the news that, because of the fumes coming off of this spill, there were several neighborhoods adjacent that were evacuated, I think, for a number of days, just out of an abundance of caution, as people could smell the gasoline coming off of the river. The next one, again, very recent, last summer, August 2022, Tri-Bar Manufacturing, the same company that the same facility that had introduced PFAS into the Huron, introduced a chemical called hexavalent chromium, or hexchrome, kind of people say for short. This was a pollutant event that reported about 8,000 pounds of hexavalent chromium released. It's a toxic metal. It's a heavy metal. It's toxic for human health and for wildlife. This resulted in, within our parks, a 10-day closure period of all of our aquatic facilities, all of our beaches, all of our boat rentals, all of those types of facilities. There's a no contact recommendation for the entire water body from the wastewater treatment plant, again, down all the way down the Huron. There were some severe concerns about drinking water impacts. I know for the Ann Arbor water plants that were concerned about, is this chemical going to get into the drinking water, and are the facilities equipped to remove it? And a whole lot of after effects, one of them being public trust, being that this was, the second pollution event in a few years from the same facility that caused the same closure and the same, there's a lot of panic about, where is this going? What's going to happen here? How do we get this stuff out of the water? So Hexavalent Chromium, it came from this plant that does chrome. They do chrome plating of plastics generally. So things like your center console in your car or the trim around your radio, those sort of chrome plastic pieces, that's what they were using this chemical for. And they were actually using PFAS as some of the suppressant in the same process to suppress the metal vapors and keep their staff safe. So again, we got really lucky with this one, sort of by chance and by having a really good wastewater treatment plant operator. We got lucky with this release. Of those 8,000 pounds that were reported to be released, much of that was caught in the filters that were actually installed for PFAS. So just sort of by luck, those filters caught a lot of this chromium and sort of the chromium clogged up the filters and it never left the plant. And then some of the wastewater treatment plant folks noticed some things that were off with their influent water, with the water coming in, and were able to get a lot of that hex chrome that did escape the plant treated before it entered the water. So a lot of scare, 10 days of closure, a lot of concern, but ultimately very little, just by sheer luck, was released into the Huron. So some point source pollution remedies. We'll talk a little bit about that. Litigation is very difficult to pursue and win for affected parties. There's a lot of reasons behind that, but one is it's very difficult to quantify damages. If something's released upstream and flows through your property and then continues downstream, it's very difficult to say how that impacted you. Polluters are often not legally liable due to the conditions of their permit or the lack of classification for spilled industrial pollutants. Things like PFAS are not, even though it's been an issue for decades in the United States, it's still considered and regulated as an emerging contaminant by the EPA. Fingers are often pointed at each other between the polluters, regulators, and wastewater treatment plant operators, where the wastewater treatment folks are saying, you shouldn't have sent us this stuff. The polluters are saying, well, we told you we were going to send it, or the state didn't tell us we needed to tell you that we were going to send it. So there's a lot of finger pointing about who's to blame and in these events. And then pollution cleanup is often not feasible due to dilution, movement downstream. It's very difficult to trace these materials as they move down a natural water body that could span, dozens or hundreds of miles and be millions and millions of gallons of water. How do you trace those pollutants? And then a lack of industrial cleanup methodology. So in the case of PFAS, because it was never intended to be introduced to natural systems, we don't really know how to get it out. And then that's something that can be a problem. And then many pollutants are legacy pollutants, or they're left behind by a previous landowner or facility operator. Case in point, the Ford plant that had left a big tank down at Flat Rock, which is now owned by Flat Rock Metals, a metal company. They were unaware this is a legacy pollutant. So, who's to blame or who's to clean this up? The federal government has done a good job in some of these major pollutant events to create super funds or brownfield sites where they have a number of large landowners and then some federal funding, which kind of comes together to clean up these legacy pollutants or things where the landowner or the polluter may have moved on and the pollution wasn't discovered until much later. So moving on from pollution, one of the other concerns with aquatic resources, and particularly lakes, inland lakes, and the Great Lakes, is shoreline erosion. So the first thing to understand is erosion and deposition are natural processes of lake ecology. Is a normal process that occurs with or without human presence there. Severe erosion is generally created by the interruption of that lake process or the loss of that natural lake process due to something else that we've done to the lakes. Seawall, or you've probably seen that kind of really hard metal wall that we may put along some shorelines. That seawall begets more seawall, and there are some regulatory concerns and some riparian rights, or the rights of landowners that are on lakes. Those are riparian owners. Some of their rights, it can be an issue for shoreline erosion. We talk a little bit more about that. And then with climate change, we've got increased intensity and increased frequency of storm events, of rain events. We're getting bigger storms and more frequent storms. And with that increased water, that precipitation, more water, more force. So that's going to increase the erosive force particularly water running off of the landscape, eroding down into the lakes, and then also storms, more wave action, more erosion. And the loss of native vegetation snowballs that effect. So you can see on the left-hand side there, sort of a natural Michigan shoreline where you see this vegetation, this tall rooted vegetation running right to the water. But as we peel that back, as we turn it into turf grass or something else, people want sand beaches, that can create sort of a snowball effect for that erosion. So I want to talk a little bit about a few of these processes. So the natural shoreline erosion deposition cycle, and I've got a few photos here, but we'll look at those a little bit closer because I know it's kind of small. So again, the erosion and deposition is a natural process. Shorelines are always in flux. It's not something we love, especially if you're a landowner or if you're a riparian owner. You don't love to hear that your shoreline is going to be in flux, that it might be bigger this year and smaller the next year. We often like things that are static, and that can become a problem. So non-natural erosion protection, things like riprap, seawall, they may increase your overall erosion, or it may relocate the problem to somewhere else on the shoreline. And then unnatural accelerated erosion, the interruption of that erosion and deposition sediment transport cycle and the armoring of shorelines has devastating effects on fish and wildlife. We're creating barriers between land and water for things like amphibians, reptiles, birds, shorebirds, and we're removing a lot of that kind of transitional habitat between open water and terrestrial communities. So just to zoom in on one of those photos here, this is sort of the erosion and deposition cycle. This is what you see as you see the waves coming in. They're going to erode the sand off the beach and move it downstream by what's called a longshore current, or a current that goes along the shoreline. And you can see that process here. So normally the waves will come in, and as they wash up the beach and back down, you'll have that sand movement or that erosion and deposition cycle. This is kind of gets to the point of seawall begets more seawall, where you can see, one neighbor has installed this really heavy riprap, these large boulders that are intended to protect his shoreline. So you can see he's got a nice sand beach there, and he's protected his shoreline from erosion. But what that's done is migrate the force further down the shoreline. So as the water comes in and hits that hard surface, it's going to move down the shoreline and then is scouring out his neighbor's property. So as you see that come in and scour out that shoreline, what is his neighbor going to do? He's gonna want to put in his own seawall, his own protective structure, and so that in that way seawall begets more seawall, because you're moving those forces down the shore, and then your neighbor's thinking, well, hey, if I don't do something, I'm going to lose my shoreline. And then this is a marine system. So this is an ocean system, but it's the same process and the same sort of principle here. And this just shows you kind of the interruption of the erosion and deposition cycle. So the figure's kind of backwards. On the right side is before, on the left side is after. So you can see normally how this beach would look as you have this natural waves coming in, eroding, and then moving north to south, sort of depositing as it moves south. And then on the left-hand side, so they redid their harbor, and they went from a piered structure where the water and the sediment was flowing below it on the right-hand side to a solid structure where there was an interruption in that cycle. So you can see on the left-hand figure a huge buildup of sediment, sort of upslope, where that sediment was not able to transport down and around that harbor. And then on the south side of that same segment, you see that huge carving out of the landscape as the currents are not able to deposit sediment down current, and they continue to have those erosive forces, but the deposition is interrupted. So you can see that dotted line of sort of, this is where the shoreline was before they created this impasse, and now that they have, you see just a huge erosive force on the southern side of that property, and you can see they're even in danger of losing some of their roads as these forces continue. So next, I want to talk a little bit about habitat fragmentation. This is a major threat, particularly with expanded urbanization and urban and ex-urban areas, and suburban areas. So on the left here, you see kind of a depiction of fragmentation where you're driving a road or a power line or something down the middle of a habitat. So you've got interior species and edge species, and different species thrive. They need large contiguous habitats, or certain species, really like deer, really thrive on edge, where they're able to get into protection and then get out and forage between the interior and the exterior habitats. So when you drive a road or something down the middle of those habitats, you essentially create what you see on the right-hand side of that photo, where you've got mostly edge and very little interior. And sometimes those interior units are just not big enough to support the same sort of wildlife as it was when it was intact. So fragmentation reduces the quality of the habitats, the contiguous habitat that's critical for some species. It can interrupt foraging, breeding, migration patterns. It can prevent access to critical habitat zones, such as fish spawning zones, or as we talked before about, thermal refugia. If you take a road and drive it right down the middle of a wetland, maybe you've separated the shallow spawning habitat from the deep thermal refugia zones, so you can create that fragmentation that way. And then the center there, you see a turtle trying to cross the road, maybe to get to spawning habitat, or to find a mate, or to forage, and that can cause obviously a lot of take or the death of those animals as they try to cross man-made features. And then on the right-hand side, kind of quintessential habitat fragmentation interruption, a dam, separating downstream species from their upstream spawning habitats, where they're not able to traverse up that dam. And then just with habitat fragmentation, important to understand that the whole of the habitat is more than the sum of the parts. That kind of goes towards the intactness of those interior species. But 1,000-acre habitat is worth more than 2 500-acre habitats. It just is. That's just the kind of how the ecology works. Where if you continue to subdivide habitats, you're going to have increasingly you're having a loss of biodiversity and a continued loss of species, or the quality and biodiversity of those habitats is going to go down. Want to talk a little bit as well about climate and microclimate regulation. So aquatic resources regulate local microclimates. They absorb heat, energy during daylight hours. They buffer rapid heating. Obviously, if you got concrete and everybody walked across the parking lot on a hot day, that absorbs heat and holds it, really quickly, as opposed to a natural system, a wetland, or aquatic resource that has a larger heat capacity. So it's able to absorb that energy more slowly, and then also releases it more slowly at night. If you walk across parking lot at night, it's going to be cold because it's released all of that energy back to the system very quickly, as opposed to aquatic resources help insulate soils, insulate habitats, and kind of they have a role to play in large macro climate and climate preservation, but in a real way, they help with local microclimate regulation as well. So it results in essentially lower highs and higher lows, less extreme and rapid fluctuation. And you can see on the right just an example of the heat absorption and retention of what they call a heat island or an urban center versus a more natural system, where you're able to have more natural transpiration and evaporation of water, and you'll have better groundwater penetration as well. So those are all the challenges, and they can get really negative. So I wanted to get to some good news here. So the good news is there's opportunities to remedy many of the mistakes that we've made in the past for aquatic resource management. There's a lot of federal, regional, state, and local authorities that recognize the value of aquatic resources, starting to put dollar figures on the value of some of these areas in terms of the recreational, economic, and environmental value of these properties. And then there's hundreds or thousands of projects across Michigan and across the United States that are being designed to restore historical aquatic function, or to convert gray infrastructure or hardscape concrete infrastructure to more green infrastructure or natural infrastructure, to restore the habitat of critical species and to create those recreational opportunities in a way that's compatible with the conservation of the resource. So hardscape reduction, these are opportunities to protect natural water bodies from stormwater pollution. You can see on the top here, this big buffer of native plants. It's great for pollinators. It also, those native plants are going to have a lot deeper root system and absorb a lot more water than turf grass. So you can see off of this neighborhood road, the water runs down into this system and it's able to be buffered. A lot of the nutrients are taken out of it and it's able to absorb, it's able to penetrate into the ground naturally via the groundwater rather than being shunted off to some pipe and then into some river. And the conversion of these traditional areas to tall grass or NOMO zones or stormwater filtration swales, it's a huge part of design these days, and pretty much every modern parking lot is going to have some feature like this. The removal of pavement or hardscape, sometimes folks are grinding up concrete roads to create more of a gravel road and increase some of the permeability of that surface. Or you can see in the bottom picture there, the use of semi-permeable pavers where there's spaces between the concrete that allows a little bit more water filtration. And then the big part with this hardscape reduction is fighting a cultural aesthetic, getting people to be happy and appreciate the beauty of tall grass and tall plants. We have a lot of, the 70s golf course aesthetic of turf grass to concrete. That's sometimes the biggest hurdle is fighting that and convincing folks that the investment of the conversion of some of these features are worth it. Another big movement within the aquatic resources field is the restoration of natural hydrology. So dam removal projects are underway in pretty much every community in Michigan. I know it's a big goal of the state to get a lot of these legacy dams removed. At one point in our history, we just put dams in everywhere. And this is an effort to undo some of those projects. So you can see here, this was a dam that was removed up north, I think a little bit, I forget exactly where. But you can see that the natural course of the river taking shape, where all that brown vegetation was all the way to the wood line would have been an impounded lake before, or a water that was built up behind a dam that would have flooded that whole area, creating an artificial lake, creating a shallow lake. But a lot of work has been done to remove that dam and then restore that original hydrology, give the river its natural course back and restore some of that floodplain habitat. And then on the right-hand side, you can see that's the same project there, as you see all those floodplain trees that were cut down at one point or died through the course of that impoundment and flooding. That floodplain and that floodplain forest is going to be restored to its natural state. And this can release impounded water that's stuck behind a dam. It helps restore sediment transport regimes. We talked about kind of the lake system transport regimes. There's a similar one for riverine systems. It helps restore wildlife passage and then habitat. It's going to improve the habitat along the course of the river. So this is one that we're working on at the Metroparks. The Flat Rock and Huron dams are on the Huron River in the city of Flat Rock. There's two dams that are right in sequence. One is for some reason owned by the Metroparks. We don't have a park there, but for whatever reason, at some point in history, we inherited this dam and this property. So we are working with state, federal, local partners, NGOs, other municipalities to do some feasibility studies on the removal of both of these dams. The other dam is the Huron Dam, which is in a park, and I think it's Huron Park in the city of Flat Rock. So a lot of movement, a lot of funding behind these projects, and to understand the feasibility. These are extremely complex political projects, huge engineering feats. So there's a lot of study underway on what would be the best course to remove these features and what would be all the complications and all the benefits, and are there pollution issues or legacy pollutants in the sediment, and all these kind of questions. These are under investigation now with the hopes to come to a point where these dams could be removed and that original hydrology could be restored. This is another one that we are working on. This is the Chago pond in quotations. This used to be a pond. It was an impounded pond where there was a dam structure in place, a water control structure. That water control structure actually failed, and it failed in kind of a nice way for us, where it was very low impact. It just led to the slow draining of this impounded pond and sort of restored the natural hydrology. And you can see there in the middle of the former footprint of the pond, where it was impounded or kind of artificially flooded by that water control structure, it's returned to more of its natural course. And this is part of the Regan Drain, which is one of the tributaries to the Huron River. And here's some other photos that I took here. This is kind of directly after the draining, where you see this, you know, kind of really dried out landscape. You can see all the shells from all the invertebrate species in there. And this is kind of what it looked like immediately after. And then on the right side, this was our plan to restore it with kind of a tiered emergent and then wet mesic and mesic prairie sort of transition to restore it to more of a natural sort of floodplain. And then while we're in planning for this is what it looks like now. This is what it looks like today. So it's incredible to me how quickly and nicely this responded on its own. There's a little bit of Phragmites in there, but overall, I mean, it's beautiful to me to see how quickly the landscape rebounded once its natural hydrology was restored. And to me, this is my aesthetic. Rather than mowed turf to pond, I really love this, and it's great to see this, and just looking forward to our continued progress as we try to increase the diversity and improve the hydrology of this area. And we're also going to be kind of creating, you know, some recreational access opportunities too, because that's part of our mission. So this is at Lake Erie Metro Park. This is a marsh restoration. It was a hydraulic and mechanical dredging of sediment that was deposited over decades and decades. Sediment deposition, again, is a natural process, but the invasion of Phragmites, which is an invasive reed, kind of increased the rate of that deposition of sediment, which kind of clogged up this whole basin of the marsh and really interrupted the hydrology. So this project is a multi-million-dollar project funded through NOAA that the goal is to maintain water in the marsh even during low water periods. And it also is improving the marsh hydrology overall by reconnecting portions of the marsh through some infrastructure pieces that were collapsed. A culvert that went under a road that was totally collapsed was replaced, and that restored the hydrology. And you can see here on the left-hand side, that's the dredging machine, which is kind of a cool piece of equipment. The top right, that was the dredging path. So you can see during low water conditions, the only reason the marsh has any water is that dredge path. So otherwise it would be almost completely dry. And then the bottom right picture, that is the marsh on the other side of the road, which shows that kind of the connectivity that was made by replacing that culvert allowed water to be conveyed down the dredge path through the culvert and into that other marsh, which is, you can see all the birds in there. They're loving it. So this is a great project for us, and we're still in the construction period for that. So talk a little bit about opportunities for increasing habitat connectivity. Reconnecting fragmented habitats with wild corridors can be an extremely effective method of restoring that connection and reducing the fragmentation that's created by things like roads, highways. So you can see here a couple of photos of these green overpasses. These are, I think, in Europe. Europe's a little bit ahead of us on this. They've got these fantastic wildlife corridors. So I know there's a whole bunch of these projects going on in the United States too, but you know, large green corridors that go over highways that allow migrations of, you know, deer and elk and other species to migrate over the road safely. The animals are pretty savvy. They learn pretty quickly that this is a safe passage over the highway, and it's very well utilized. There's a lot of data behind that. In the middle there, you can see this is one for a marine environment where it's a crab migration, and they created this sort of crab ladder over the highway, which is really cool to see. Obviously very purpose-built. Not a lot of animals getting over that aren't a crab. So they were able to climb up and over and get to sort of mating and breeding grounds between the ocean and that more upland corridor. And then on the bottom right here, just some deer enjoying an underpass under a highway where they're able to safely get under a highway and move between habitats that were formerly fragmented by a roadway. This is at Lake St. Clair Metro Park. I know I'm getting short on time, so I'm trying to hurry through these here. This is at Lake St. Clair Metro Park. This is a turtle tunnel that we've designed, and this will allow passage of turtles, amphibians, herptile species under the roadway. It's sort of specially designed to cater to those species by its design, its ability to let light into the system, the width and depth, and all of those features are sort of specially designed to allow for access of these wildlife species. And then on the bottom right, you can see our survey, which shows, just the amount of species and the number of species we have immediately adjacent to the road, and how, the initial construction of that road moving east to west really split in half what was a very large marsh, maybe 500-acre marsh, kind of split it into two 250-acre marshes. So this will be an effort to sort of reconnect that habitat. Nutrient pollution and runoff reduction. So natural shorelines. These are riparian buffer zones. They reduce the speed of water and its delivery to the river. They filter out nutrients and pollution. They provide wildlife and pollinator habitat, and they enhance the shoreline for herptile species, a turtle or snake or reptile's ability to move up the shoreline. They don't have to climb over riprap or over a seawall. They've got this sort of natural transition between open water and upland area that they're able to transition through. So these restorations often remove hardscape materials. They soften the shoreline slopes, kind of peel back the slope to a more natural feature, which allows for the establishment of this vegetation. It enhances the wildlife usage, and it still maintains the protection of the shoreline from erosion. And it does, I think, add a lot of aesthetic beauty as well. And we've got 2 of these projects going on now, and I'm sure there's dozens or hundreds across Michigan. So this is one of them we have going on right now out at Lake Erie Metro Park. Hard to see unless you're used to looking at these engineered drawings, but on the top you have sort of our shoreline as it exists now, that mowed turf right to riprap. And then on the bottom, those are the plans to sort of grade back that shoreline, create some fishing habitat, lessen the slope. Right now it's about a 2-foot drop from the top of the turf grass to the water. So this will lessen the slope, create a 20 to 25 on one run, which will kind of create that kind of flat floodplain wash area that species, that native species can establish in, and that species can utilize to access terrestrial habitats. So there's going to be woody debris and rock structures that will sort of enhance fishing habitat and spawning habitat there. And it will help. This is part of that same project that's with the dredging to restore some of the marsh hydrology. This is kind of an adjacent habitat where we're going to be doing some shoreline softening. And this project is scheduled to get underway any day now. So if you're out at Lake Erie Metro Park this time next year, this project will be installed. Lake St. Clair Metro Parks, another one of our metro parks in Macomb County. This is a natural shoreline project that we did. You can see sort of the original conditions here with the concrete slabs and riprap and exposed rebar and some really nasty features that were used to sort of protect the shoreline. A lot of this was kind of waste left over from highway demolition that was used to anchor and reinforce the shoreline. Had almost no native vegetation and pretty much ran turf grass right to the water. So what we did, you can see on the bottom right here, this was some of the concrete that we removed. You can see how these big nasty chunks of concrete and asphalt waste were sort of what was in the shoreline before. So again, looking at the project that's going underway now, we did a lot of grading, kind of easing the slope and the transition from the water to the land. We have kind of some quarter log material installed at the edge for sediment control. And this is just some of the grading, kind of easing of that slope. This is more what it looks like now. You can see we put down all this barrier to protect against erosion again, and there's seed under that blanket as well. So as the shoreline was graded, it was seeded with kind of a native mesic species or wet mesic species mix, and covered with this blanket. So then hopefully this time next year again, we'll see a nice grass and pollinator species filled shoreline there.
That's great. Have a couple more slides, kind of coming down to it.
I'll go quickly here. So we installed some duck habitat as well for duck nesting boxes for wood ducks and mallards. This is at Willow Metro Park, is another shoreline stabilization project. We had a huge eroded shoreline that we enhanced in order to kind of create soil lifts and protect that shoreline from further erosion. And then management activities. I don't know if we have time to get into this, Lisa, or do we want to?
I think we probably need to kind of wrap up so that folks can get to where they need to go at the top of the hour here. Yeah. No, and Tyler, it's great to see, right, all of the things that are that can mitigate, and all of the ways that, as you said, the ecosystem responds. And let me throw you one question before we wrap it up so that folks can get to where they need to go.
Sure.
Are the turtle tunnel plans online anywhere?
They're maybe online in some of our board packet approvals, but we don't have a project page for it yet. But as we get that project kicked off, there will be a project page for it on our website. Okay, great. Yeah. Well, thank you for sharing so much of the great work that you all are doing at HCMA. Really appreciate it. And thank you all online for tuning in. Really great to see the ways that as we learn how systems work and how they respond, that they really do respond to the helpful human actions to steward them. So again, thanks, Tyler. Really appreciate you being here with us today. Thank you all online for joining us. If you want to stay tuned to what's happening at the Stewardship Network, go to our email sign-up page. We'd love to get you in the loop. We'll be back here next month on the second Wednesday of each and every every month. We'll be joining Emily, who will be talking about invasive species. And hold on, we will also be kicking off the Stewardship Network Spring Challenge. So looking forward to talking to you about that next month. Again, thank you all for joining us. Hope you all have a great rest of your day. Thank you.